Hello everyone, very good morning. This is Mithilesh Singh and you are watching my CloudX India YouTube channel. Guys, if you did not subscribe my channel, I'll request you to please subscribe and share with your friend if you like the content. Okay, so in this topic, as I said, I'll talk about the load balancer. Okay, before moving to discuss about the load balancer, we have to understand the situation and the problems why to use the load balancer. Okay, suppose you have a server which is your web application server and the server configuration is 16 CPU and 64 GB RAM. And you assume, or as a technical person, you expect it can handle around 2000 requests. 2000 requests in it means the end user request it can handle around 2000 without any problem. Okay, so let's talk how the connection established and what happen if requests increase from 2000 to above. Then what happened with your application server? Okay, the first request come, second, third, fourth, 15, and like the requests coming. Okay, multiple requests come to your system and it reached around 1700 to 1800 connection. Means the 17 to 1800 users connected with your web applications. What happened if connection reached to 17 to 1800 with your web application? So as soon as the connection reached till 1800, the CPU utilization or your system's utilization increased till 40%. Okay, so if limit like utilization increased to 40, I do not see any problem because 40 is the good. My system is still in good health status, I can say. Okay, what happened if the request again increase and it increase multiple requests around 2000 connection? Whatever you expected or you assumed before that the ideal condition of my web server to handle around 2000 requests and now the connection increased till 2000. Okay, so as soon as the connection increased till 2000, you were expecting the load increase till 60 to 70%. And the load increased. As per your expectation, the load increased. Okay. And the worst condition, what you were not expected before. Now, today or someday, the connection goes more than 2000. Okay, suppose your website become very popular among all and the connection and the request all of a sudden increase from 2000 to like above 2000. Then what happened in this situation? What happened if increase request increase more than 2000? If connection was 17 to 1800, then your limitation like the CPU utilization goes 40%. If it reaches to 2000, then the utilization of your system become 60 to 70%. And what happened if it crossed the threshold? Whatever you expected or you assumed, it increased the limit more than this. Okay. As soon as the increase limit beyond your expectation, like more than 2000 to you can assume around 5000 or you assume 3000 whatever, right? The connection increase more than 2000. As soon as the connection increase more than your expectation, the utilization of your system also increase. It increased to 80 to 90 or more than this. And when the CPU utilization reach the threshold more than 90%, your system become in it your system will come in hung state. It hang. And once your system hang, it stop function, right? It is stop function, and what once it stop functions, all of the end user will face the problem. So whatsoever the connection was established and whatever the connection is coming, all users will face the problem. Why they face the problem? Because your system is not functioning properly. The utilization of the system increase from here to the top, and it can be dead. Okay, what will you do in such situation? What will you do in such situation? So as a technical person, what you can do, you may increase the limit of your system. Okay, you may increase the limit from 16 CPU to 32 CPU. You may increase the limit from 64 GB RAM to 128 GB. And as you increase the limit, definitely it increase your idle condition, the numbers of requests, and your system again become available. And the end user will again start connection. But what happen if your application server goes down? Your web server goes down. You have the good status. The utilization is only 40% or less than this, or 60%. There is enough scope to establish more connection and handle the request, but all of a sudden your system goes down. And if such situation happen, then what will you do? You do not have any other options until unless you create a new system, you prepare a new system, install the application, and make it available for the end user. Till the time you do the troubleshooting whatever you are doing to make the system available again, till the time user will not have access on your web application, right? And if user do not have access on your web application, then they stop working, and it may your business critical application server, web server, right? So it stop lots of work of your organization. Your organization lose lots of money because of this, because your mission critical application is set up and dependent on a single system, right? Single system means one system, and once it goes down, everything goes away. Everything is down. Okay, so to solve this problem, that is the main purpose of the load balancer, right? How to resolve such a problem, right? Okay, in the next topic, I have few more detail which help you to understand how to set up and how to get rid of from this situation. Okay, so let's talk about the next. Now your web applications. Okay, so the problem was in before, like once you have a single web application server, the problem was single point failure. If this system goes down, your application stop working because this is the single system which is holding the application. Okay, and if load increase, then and it goes to a certain point like 92 above, so what happened, it also dead. Okay, so the problem you saw, there are multiple problems: system availability, load sharing, high availability, right? To make any applications highly available, you have to think about the failover, how to failover, how to create failover plan, how to balance the load, how to distribute the load among multiple systems. Okay, so let's talk about this. But before this, we have seen that our application was not highly available. The first question come in mind, is your application highly available? Definitely it was not if you're using a single system. How can you make it highly available? We'll talk about it. And the second question come in mind, what is HA? Highly available, it means you want your application all time running. But what is HA? How does it work, right? So HA is, you can say, the full form of HA is high availability. And high availability is a quality of a system or component that assures a high level of operation performance for a given period of time. Okay. The next thing, is there any way to route the end user request to multiple systems? Suppose you make your system highly available, you set up another server. Here, you set up another server to make it highly available so that if this system goes down, this system will available to cater the end user request. But how will you do this? So we'll talk about, we can achieve this with the load balancer. And the second question come in mind, if you have two systems available for your application, is this not possible to route end user request? There is some sort of like technique we use, and whenever there is a user request come, right, so it your application automatically redirect the request on this system, then this system, this system, then this system, like this. And in case there is any failure, it route all the users requests on the healthy node. So definitely this is a possible with your load balancer. So we'll talk how does it work. So the third question, is there any way to route the end user request to multiple systems? Definitely yes, with the load balancer you can do this. Okay, so what happened? The end user request will come to the load balancer, and load balancer balance the request. It route the traffic accordingly on this system, this system, this system, this system. It route the request. Okay, the next question come in mind. What is load balancer? So the load balancer is a group of multiple identical system which serve the services. Load balancer also help to route the traffic to multiple healthy nodes and provide high availability. Okay, so this is very simple and clear. What does it mean and how does it work? Its load balance is a group of multiple identical system. Identical system, it means when you are going to provision another system to make your system or application highly available, then you have to make sure that whatever you have configured here, whatever the application install or data is there, the same thing you have to replicate here as well with the same configuration. Okay, this is what you have to consider in your configuration. Okay, because the load balancer, what it does, it simply listen the request of end user, right? It listen the request and route to the traffic to any of the healthy node. Listen the request and send the traffic to any host. Listen the request and send traffic to any host. And doing this, basically it's balancing the load. And in case this system goes down, what happen? It will not send the request on this. User will still connect to this endpoint because user is not worry about this, right? What is happening in backend, user really doesn't know. So what happen, user will always connect to the load balancer, and load balancer see, oh, this is unhealthy, down, let me send request to this healthy node. And once the system become healthy, what happen, your load balancer again start sending request to this as well. Okay, so this is the basic idea. What is the load balancer? Okay, and how does it work? In next slide you will get more idea about load balancer. Okay, so let's move to the next slide. So suppose you have created a load balancer, and to this load balancer you have assigned a name, demo.com. Any name as per your requirement you can do, but for the practice I'll suggest to use this demo.com. Okay, this is the load balancer. Load balancer you create for high availability to route the traffic. Okay, and you have an application server. LB. LB means your load balancer. Check health status of backend server. So as soon as you add your, let me take the highlighter here. As soon as you take the add your server into the load balancer, the first thing of load balancer is to check the health status of backend server. Means this server, this is backend server. The question come in mind, how does it check health status? Is there any way? How does it check? Is your load balancer and application server exchange heartbeat? Okay, so let's see. How does your load balancer check the health status? So during the load balancer creation, load balancer create a rule, which is a health check rule. Okay, in the health check rule, what it does, basically there are certain parameter which you have to define. This is a most important parameter. The first thing we'll talk about the later on as well. Okay, the first thing, it configure a protocol which is HTTP ping protocol and use it as a ping protocol, and the protocol's port number, ping port, which is 80, whatever you can modify it as well, and ping path, any file name you can the file name should be, if you have installed IAS, then make sure you create a HTML file and you configure it here, and make sure you do not remove the root sign, the slash sign. Okay, because if you remove it, then it will not let you configure it. So make sure you use the slash, then html.health. Okay, so there are three conditions on the load balancer health check. I define first ping protocol, that is HTTP, ping port, that is a port 80, you can modify it, and ping path health.html. Okay, so this is I configured at my load balancer. What happened to backend server? So if you are using ping port here, make sure that port 80 is running and accessible on your web server. The first thing. And the HTTP, definitely it's supporting to HTTP. So first two thing is clear. I configured ping protocol, HTTP, and ping port I allowed here, port 80. Means I configured my application on port 80. The second thing, you have to create a file here. And this file, your health.html, and the same file name you have to give into the ping path. If you select any other file name and this file is not available on your health web server, then your load balancer understand is unhealthy. So make sure the health.html is there, or whatever you file create like test.html, that should be here. So that should be the same. So once you create these two things, like allow the port 80 and create a health.html and configure here, so what happen? Your load balancer will talk to your web server. It ping the protocol HTTP, ping the port 80, and ping this path or access this path health.html. If your IaaS services is running, port 80 is configured, then this load balancer is able to communicate to this web server and consider it as a healthy node. So this is the basic thing you have to do it. Okay, if you do not, if you miss anything, if there is any mismatch in your rule, okay, in your rule and the configuration at the web server, then this load balancer will consider it unhealthy. Okay, so what happened next? If you have another server, web server, in your load balancer, so make sure all other servers should have the identical configuration, because this load balancer is using this rule, health rule, to connect and verify whether host is backend server is healthy or not. So on every server you have port 80 and health.html. Okay, right. So now let's see what happened. Your server is ready, all backend server is healthy, Now the end user will make a call. It type demo.com at a system and connect to the load balancer. As soon as it reaches to the load balancer verify it already checked which is the healthy and which is not, and see, oh, so there are four healthy node. Let me send this request to this node. It can send to any of this. Okay, so don't think that it will send to the first node. It can send to any of healthy node. Okay, and the next request come, it's sent to the another system. Third request come, it's sent to the third system. Fourth request come and it's sent to the fourth server. In this way, your load balancer work. Okay, it listen the request sent to the any of healthy node, and it route the traffic. Always remember, okay, it route the traffic. Request coming to this load balancer. Suppose after 2 days, this user again come and make a call. So what happened this time? It may your load balancer may connect to this system, this user request to this node. So this is not fixed that the single user will always connect to one node. Yes, there is some configuration which you can like enable like a sticky session, and then you can configure this so that this request goes on particular like what whenever it connect again, right? So it can resume the session or connect to the same host when to which it was connected before. That is the different thing. Okay, so this is the load balancer configuration. Okay, what happened guys if IIS services is not running on this host, or someone modify the port configuration at the IIS level? If IIS is not running, what happened? It response timeout, it wait for 5 second, interval 30 second, unhealthy threshold 2, unhealthy threshold 10. Okay, this is the value which is it there is configured. What happened in every this time period in interval and response timeout, it verify, oh, this system is not reporting, or I am not able to ping to this port path and port number. What happened? It consider it unhealthy. Either IS services is not running, or someone modified the port, or someone changed the file. In any case, what happened if there is anything missing? System is not running, hung status, rebooted, someone stopped the services. What happened? It will not able to, the load balancer is not able to communicate to this. And if it's not able to communicate to this node, what happened? It mark it unhealthy. And the next time, whatever the request is coming, it never sent to this. It always sent to any of three. As soon as the problem fix, issue resolve, what happened? It make it healthy again and it start sending the request. So guys, you understand, I hope, definitely you understand in this topic. So if there is any mission critical data or any web application, so you should always mm, like you should have multiple web server running in your organization, like one more than one, right? And the application server should configure behind the load balancer. So your load balancer will work as a front end. Every request come to this load balancer, and this load balancer route the traffic to your backend healthy node. Okay, so in this situation, you can make your system highly available. Highly available how? If this is goes down or this goes down, what happens? Still you have two server. Okay, and second thing, it also handle the load. Handle load means if request is coming, it's you can see it's suppose sending request to this, and the next request is to this, third request to this, fourth request to this. So what is happening? If there is 100 request, it distribute all requests in 25, 25, 25. Okay, so what is happening? 100% load is equally distributed on four hosts. The utilization of all system is 25% only. And if there was one system, what happened? The utilization of system goes high and the system goes dead. User will not able to connect, right? So in any idle situation in any organization, right? Everyone using the load balancer, right? If it is a on premises, they are using the NLB or failover clustering, NLB for the web services, right? And on the cloud, they have the on AWS, there are different way of using like load balancer, classic, application, and network. In next topic, you can see my video, right? So where I will talk about what is the application load balancer, what is the classic load balancer, what is the network load balancer. So there are three types of load balancer which AWS provide. Okay. So in next topic, I'll talk about that one. So this is the classic load balancer scenario, or you can say the load balancer scenario. Okay. I hope you enjoy the video. If really you enjoy the video, please comment on comment section, and also share this video with your friend and subscribe my channel. Thanks guys. Thanks for watching the video.